Alright, chemistry students, welcome back. So, I promised that I would post one more video showing you how this stoichiometry process can be done when you don't have moles of a substance. So, in our last video, we took a look at this simple balanced equation of nitrogen gas and hydrogen gas reacting to form ammonia. And we asked a question that said, okay, if we had 3 moles of nitrogen gas and they were allowed to go through this reaction, how many moles of ammonia would be produced? And we came up with this answer. So we said, okay, we start with 3 moles of N2. For every mole of N2 that we consumed, we produce 2 moles of ammonia through the reaction. We would say that the mole ratio between nitrogen and ammonia is 1 to 2. So we put moles of nitrogen on the bottom, we put moles of NH3 on the top, and then we multiply. 3 times 2 means that we would produce 6 moles of NH3. Now, that problem was overall pretty simple. We can make this a little bit more complicated by saying, okay, what if instead of 3 moles, we had 3 grams of N2? And we want to know how many grams of NH3 will be produced. This is a much more practical question because we can weigh out a certain amount of N2 and a certain amount of NH3, and then that makes this like a real chemistry problem. So, how would we go about solving this? Well, the issue here is that these numbers don't relate the amount in grams of these substances. The only thing that they relate is the number of molecules or moles. We know that 1 mole of N2 consumed in the reaction will produce 2 moles of NH3. We don't know how many grams of N2 will produce how many grams of NH3. So that creates a problem. And the way to solve that problem is we know how to convert between moles and grams of a substance. We know that 1 mole of any substance is equal to the atomic mass of that substance in grams. So that makes this a fairly easy thing to solve. So let's see how we would do that. We're starting with 3 grams of N2. We've established that once we get to the mole step, we know how to do that work. We know how to do this work to get from moles of N2 to moles of NH3. So our goal should be to get from grams of N2 into moles, convert from moles of N2 into moles of NH3, and then convert from moles of NH3 into grams. So we have to get into moles in order to do the stoichiometry work. So let's go through and do that. So we'll convert from grams of N2 into moles of N2. And we know that a mole of any substance is equal to that substance's atomic mass in grams. So how much is the atomic mass of N2? Well, we know that nitrogen weighs 14. N2 contains 2 nitrogens, so the atomic mass of N2 would be 28. We know that 1 mole of N2 weighs 28 grams. So 28 grams of N2 is equal to 1 mole of N2. And if we stop the problem then, that would tell us how many moles of N2 is equal to 3 grams of N2. However, we're not going to stop the problem. We're going to continue on. Now that we're in moles of N2, we can say, okay, well, how many moles of NH3 will be produced from that many moles of N2? So we're back to doing stoichiometry. We know that for every 1 mole of N2 consumed, we produce 2 moles of NH3. And if we stop the problem now, that would tell us how many moles of NH3 were produced. Again, that's not what the problem asked for. The problem asked for how many grams of NH3 will be produced. So once we have moles of NH3, we can say, okay, we can convert between moles and grams. Because 1 mole of any substance is equal to that substance's atomic mass in grams. So how much does a mole of NH3 weigh? Well, how much does a mole of NH3 weigh? So we know that 1 nitrogen weighs 14, and we know that 1 hydrogen weighs 1. So we have 1 nitrogen and 3 hydrogens, 14, plus 3 times 1, or a total of 17 grams. Again, nitrogen weighs 14, plus 3 hydrogens, each weighing 1, which gives us a total of 17 grams. So we can convert one final time from moles of NH3 into grams of NH3 using the atomic mass as a conversion factor. 1 mole of NH3 equals 17 grams of NH3. And then all we need to do is throw this number into our calculator. So, clearing out our problem from before, we have 3 divided by 28 times 2 times 17. And that gives us a total of 3.64 grams of NH3 produced from this reaction. So this is the mass of ammonia that would be produced from reacting completely 3 grams of nitrogen through this reaction process. If we started with 3 grams of N2 and all of it reacted, we would end up with 3.64 grams of NH3. Again, to reiterate the process, we converted from grams to moles. That's this work right here, converting from grams to moles using the atomic mass. Then we use stoichiometry to convert from moles of one substance in a chemical equation into moles of another substance. That's this work right here. Then, once we had moles of NH3, we again converted from moles into grams using the atomic mass as a conversion factor. That's this work right here. It's all done in individual steps, and we combine that into one railroad diagram so we can put it into our calculator all at once. And that gives us the answer of 3.64 grams of NH3. That's about as complicated as these problems get. Every single problem that we do involving stoichiometry will involve these steps. We'll take whatever we're given in the problem, convert it into moles, use our mole ratio to figure out how many moles of another substance will be produced, and then whatever we get out in moles will convert into whatever the problem asks us to convert for. In this case, we converted grams to moles, converted moles to moles using stoichiometry, and then converted from moles to grams. I hope that was helpful. Leave anything that you learned in the comments or anything that you needed me to clarify, and I will help you understand it. Thank you very much, and I will see you in class.